Yeah, I know. All right, let's look at this. Okay, it's the same thing. Number 3, okay.
My laptop didn't let me sign into it with this Gmail, so I had to do it on my other computer, but it didn't have a camera.
Okay, no worries. How's everything though?
Good.
Yeah, I know it's been a while. So I mean, not really. It's like been a week, but were you able to practice the worksheets from last time?
Yeah.
Okay, I'm actually just looking at. Maybe we'll do like a review here today, just to check like which ones have you. So like for school, how far are you guys in your math? Like, have you guys covered equations?
We're doing two-step equations.
Okay. Oh, that's kind of like what we've covered. What about inequalities? Did you guys start doing that?
Not yet.
Okay. And then no graphing yet, right? Like for equations?
No.
No. Okay, maybe we'll cover somewhat graphing. I really wanted to, because that's kind of like one of the most important parts of like algebra is like after you do, you know, the manipulations and simplifications, you have to like graph either like in a 2D. We'll talk about it in a bit, but let's see. Maybe let's do this one first. So, do you remember doing exponents? Just
Yeah.
the different rules. I know the more you practice it, the better you're at like, you know, remembering what each rule was. Do you remember the rules that we talked about?
Yeah.
Okay. Okay, so I'm not gonna talk about that then. Let's just go over some examples. So let's try to do like some of these just to warm up before we cover solving equations and then graphing them. So let's take a look at this guy and let's see if we can get some of this, and then I'll cover the answer. So something like this. What's the very first thing that you have to do with negative exponents?
Multiply the 4 to everyone.
Okay, so you would multiply this guy. So let me just enlarge this. So you would get like x minus 8, and then y minus 12, right?
Yeah.
And then what do you do after that?
Add the exponents together.
Okay, so for this one, since you have like different bases, like you can't add them. Do you remember like when we have negative exponents, what we have to do with them?
Put them on the bottom.
Okay, so yep, that's the way that you're supposed to do that. So you know, you put it on the denominator, and then you make them positive, right?
Yeah.
And let me see. Oops. Okay. I guess I. Okay, and then what do you do now? You add
Now
them, right?
you add the exponent.
Yeah. So x to the 20th. Okay, that's good. Let's try to do something harder. What about this guy? What do you do first?
Multiply both of them.
So the 3 with the 3, right?
Yeah.
So 3 times 3. This is a little too big. Let me make this smaller. So 3 times 3, that's going to give you n to the 9. And then you have this 2n to the negative 1. What do you do next?
You can do like terms.
Okay, so this 9 and negative 1, what do you do with that one?
Add them.
Okay, so 9 minus 1, that's 8, right?
Yeah.
All right. So that's what I would do, yeah. Yeah, so these are just, just warm up. Let's try to do something where it's like a radical or a rational. Let's see. Gee, this one doesn't look that bad. Okay, let's do this one. What do you do first?
Add all the like term exponents together.
Okay, let me just do this guy first. So x times 4 times 3 and then 3. And then let's see. So you have this x squared and twice. So x 2 plus 2, right?
Yeah.
And plus 1. So that's this guy. And then you also have this y 4 plus 4, right?
Yeah.
And you have x minus 3 y squared. And let's simplify that. So 2 times 4 times 3 then. And so that's going to be x to the 5th, y to the 8th. And then you have x negative 3, y second. All right, what do you do now?
Now you put the exponents that are on the bottom that are negative onto the top.
Perfect, yeah. That's what you do. So 2 minus or times 4 times 3 over 3. So you have this x 5, and then you plus 3. Then you have y 8. What about this 2? What do you do with this 2 over here?
Keep it on the bottom.
You could minus it, right?
Yeah.
To the top, yeah. Okay, so just to get them all in like one place. So when you do that, and then since I don't want to write too much, what about this 3? What do you do with this 3? You cancel it, right?
Yeah.
Okay. And then so you just simplify. 2 times 4 is 8. X to the 5th plus 3 is x to the 8th. Y 8 minus 2 is what? 6?
Yeah.
And that's what we get. That's what they got as well. All right. Let's do something where a little bit harder. Let's try to do this guy. Okay.
Multiply the -4 to all of them.
Okay, 2 to the -4. Yeah, this is good. So p to the -4, m to the -1 times -4, q times 0 to the -4. And then you times this by 2, m to the -1, p to the 3rd, 2pq squared. All right, so let's try to write that. 2 to the -4, p -4, m to the 4th, q to the 0, 2 to the p 3rd, 2pq squared. Okay, what do you do now?
Combine like terms
Okay,
on the top. Or you
all
could
right.
put the negative exponents on the bottom.
Yeah, you could do that all at once. Let's try to do that one. So you could do like, all right, this one, 2 to the 4th, and then p to the 4th. And let's see, p to the 4th, m4, this is obviously going to go to 1. And then you have 2 right there. And then you have m at the bottom, p to the cube. And then the bottom terms now is you have 2pq squared. Let's take a look at this. And then what do? You could cancel the 2, right?
Yeah.
I cancel the 2. 1, 2, so I only have 1, 2 to work with. And then like you can cancel some of these terms. The one that are bigger, you can put them on top, right?
Yeah.
So m to the 4 minus 1. And then you have p3 up top, but then the bottom exponents are bigger. So that's 4 plus 1 minus 3. And this is to the 4th. And then you have this p plus 4 minus 3, q squared. So m third, and then 2 to the 4th. 4 plus 1, 5 minus 3, that's 2. That's 2. And then q squared. So what's 2 to the 4th? What is that? This guy.
Oh. 16.
Okay, 16. Good. P squared. Yeah, that's just a review. And that's what you have, right?
Yeah.
Okay. Okay, so that's not that bad. I think we should try do something that's related to this guy. All right, let's try do some rational expressions with different denominators. Okay, because this one is the one that that we should always review because it always comes up. Let's do this guy and see if we can get this. What do you do first?
Cross multiply.
So when you mean by that, you mean like times these guys by this guy, right?
Yeah.
Like same denominator.
Yeah.
Okay, so 7x times 20x plus 16 and minus x minus 2 times this by 2x. And then 20x plus 16 times 2x. All right, so you have 2x, 20x plus 16. I always don't I don't try to distribute them because sometimes something might cancel out. So 7x, 20x plus 16. And then what do you do with this negative? This negative right here. What do you do with this guy?
I don't know.
You distribute it, right?
Yeah.
So what I usually do is like I just do this first because like you will end up distributing it, but I would just do this first. So 2x, x minus 2, something like that. Then, so what do you do here?
So distribute all of them.
Okay, right here, right?
Yeah.
Distribute this guy. Okay, all right. So from here, you get, let's see, if the numbers aren't too high, 140x squared plus 16 times, 16 times 7. That's 2, 4, 7, we'll do 112. Is that right? 16 times, yeah, it seems like it's right. 112 x. And then the minus 2 x squared and then plus 4x divided by 2x, 20x plus 16. Man, this one, they really simplified it really well. So let's see if we can minus that. So you have this first guy, which is 138 x squared. And the other one is 116x divided by 2x, 20x plus 16. Okay, what do you do now to simplify this?
Distribute on the bottom.
So I would probably not do that yet, like because you want to cancel something out. What do you do with the top? Because there's an x squared here and an x, right?
Yeah. Then
So
add them.
you want to factor something out, kind of like
Add the
something.
exponent.
So like you know how you have this x squared, right?
Mm-hmm.
And x, and then they're being added, so you can't add the exponents, but you can take out a 2x, right? You can take out a 2x, right?
Yeah.
So let's try to take out a 2x. I think it's 69. I think you actually get this guy, the one that I have here. 69 times 2, 8, 1, yeah. And then 58 times 2 is 6, 1, 116. Yep, I think that's what they did, plus 58. And it's 2x, 20x plus 16. So that cancels out, right? The 2x cancels out.
Yeah.
So you get 69x plus 58 divided by 20x plus 16. And I think that's it. What they did here is they just factored out the 4, right?
Yeah.
This is pretty much the simplified form. I would stick with this one. Okay, so that's good. I like doing something like that because it really puts everything together. Like, oh, do you know your rationales, operations? Do you know your exponents? Do you know your arithmetic? Okay. What about let's do something harder. Let's look at this guy. I guess just to pick one. What do you do first?
Do the denominator.
Okay. So you do v minus 2, right?
Yeah.
And you times it by the one that it doesn't have it. The 6, 2v plus 7. And then you have let's see, minus, you have this 2v plus 7, and you times it by v minus 2, and 7v minus 2. Okay, and then so you have v minus 2, and then 2v plus 7. And then so what do you do with this negative?
You distribute it.
Okay, so minus 7v minus 2. Yeah, you always want to remember that. That's why I keep on asking, because like a lot of people usually forget. So now what do you do?
Distribute the parentheses on the top on the numerator.
Okay, good. So this one would be 12v plus 42 minus 7v plus 14. And then v minus 2, 2v plus 7. And then what do you do?
Combine like terms on the numerator.
Okay, good. 12v minus 7v is 5v. I think we're pretty much done after this one. 56. And then I think they did this first. And then v minus 2. That's it. That's your simplified form. Okay. Let's actually do more of these. Is there a harder one? I guess the hardest one is this guy. Let's do this guy. What's the very first thing you need to do?
Put the negatives on the top.
So for this one, there's no negative exponent. So let's see. So you know how like this guy is a whole number?
Yeah.
And there's no fraction. You always keep the rules. What's the very first thing? You need to multiply what's on one side and what that's not on the other, right?
Yeah.
So like this guy has a denominator of this right here. So I would probably just multiply that. Like let's say 3v to the fourth. Like this. Just take a look at this one because this one's a little bit weird. And then minus, every time you have a whole number, just do the same thing as what we've always done. Just multiply what's not on that whole number. So like 3v to the fourth minus 15 cubed minus 18v squared. Then, so when you do that one, and rewrite the other guy just for clarity. So you have like minus 18v squared and then v minus 2. So after that, let's see, 3v to the fourth minus 15v cubed v squared, and you rewrite it like this. This one's easy because you already have a plus here, so it's easy. Just write like this: 3v to the fourth minus 15v cubed 18v squared. Okay, what do you do now?
Distribute the numerator, the parentheses on the top.
Okay, so this guy, 1, 2, 3. So v minus 2 plus 9v to the 5 minus 45v to the fourth minus 20. So that's like 4. No, not 20. That's 4 to 54, actually. 54 minus 54v to the cube. Right? That's what you do, right? Okay. And then I think you're done. You just have to rearrange. And then at the bottom, I honestly don't think you should do anything to the bottom. So all you have to do to match the answer is just rearrange. Because nothing really, there's no like terms. And then like 3v to the fourth minus 15v cubed 18v squared. That's it. So does that make sense? When you have this whole number right here, like when you have this whole number, this guy, all you have to do is take a look at this and then make sure you times it by top and bottom, because that pretty much is the same number, right? It's just 1.
Yeah.
You're timesing 3v by 1. It doesn't change the value. But the reason why you times it by that, top and bottom, is so that you can combine these guys. Okay. Let's see. Is that the only one for this? Okay, I guess we can. Let's move on. Let's take a look at radicals now. Do you remember doing radicals?
Yeah.
Radical rationals, very much radical fractions.
Yeah.
Or fractional exponents. So what is this guy? What does this equal? 1/2,
half.
right?
Yeah.
Yeah, to the 1/2. And then what about this one?
3
to the 1/3. Yeah.
Yeah.
Okay. Yeah. So okay, do you remember these? Let's try to do something hard now. So as long as that, because that's always a thing. Like what is the? Because when you try to multiply these guys, you're gonna want to know that interchangeably so that you can simplify them. And let's see if we can do something with without the numbers. Let's do something like this guy right here, because it has like variables. What's the rule with radicals? Can you have them at the bottom? This guy right here?
No.
Okay, so what do you do?
You put them on the top and then they're negative.
Okay, let's see. What I usually do, so you have this root 5xy to the cube, right?
Yeah.
So I would times it, because there's no harm in timesing it by 1, right?
Yeah.
So this times it by 1, or in other words, this guy. I would take a look at what's at the bottom radical here and just times it by 1, like this. And then so what happens is, let's see, now you have to multiply them. So when you have, let me just rewrite it. I think it's better to say. And then you have this other guy, 5xy cubed. And then you have this guy right here, right? And this is being multiplied twice. So you're squaring it, right?
Yeah.
So when you square it, what happens? It removes the radical, right?
Mm-hmm.
Okay. So let me just rewrite the top again. Y cubed 5xy cubed. And so it's 4 times 5xy cubed. So the bottom, let's see. I'm not going to distribute it yet, but let's do something to the top now. So what do you do when you have something like this? You can put them in one radical, right?
Yeah.
So let's see, 3 times 5. And then what do you do with the exponents?
Make them negative.
So you can add them, right?
Oh, yeah.
So x squared plus 1. And then the y cubed. Let's see. So what x1, let me see, x squared. Let me actually see if this is, what was the answer? The answer is root 15x. Yeah, that should be right. Root 15, so you have 15. And the other one is y cubed plus 3. Let me think. So times it by, let me just see if that's not 15. Okay, you get 15. You get x to the cube. Looks about right. And then y to the 6. And then 4, 5xy cubed. This right here, you minus it with this guy. So that's going to be root 15. And then you have x 3 halves, y 6 halves. Do you know what I'm doing right here? So like you have this radical, right?
Yeah.
And then so I just split it because like it's easier for me to see them in their separate form, in their fractional exponent form. Because now what you want to do is you want to minus it from these guys, right?
Yeah.
Okay. So it's easier for me to see this. If you do it this way, I think this is the best idea, because then what you do here, you have 6 over 2. What is that? 6 divided by 2. That's 3, right?
Yeah.
So this is 3. And so you have y to the third minus over y to the third. That just cancels out, right?
Yeah.
What about this guy? And then this guy.
Is the denominator on the exponents 3 or 2?
3. On the denominator, it's 1. It's 1.
No, on the top.
This guy
But
is
with
3.
the extra.
3 over 2. This 3 over 2.
Oh, okay. I thought it was 3 over 3.
Okay. Okay. So what do you do with that one?
You can add them.
Okay. So this is at the bottom, right? So when you add it, you add a negative number, right?
Yeah.
So 3/2 minus 1. But what is 1? That's 2/2, right?
Yeah.
Because they're doing fractions. So 2/2. So you have root 15. Root 15, if I can write 4 times 5. So x 3/2 minus 2/2. What is that? What is this guy? This is 1/2, right?
Yeah, 1/2.
Okay, so what is 1/2? X to the 1/2. Is that a square root?
Yeah, it's half of x.
So it's 15 times the square root of x, right?
Yeah.
And then, okay, so now we're pretty much done. We just have to do some arithmetic, so a simplification. So these guys, you can combine them inside the radical, right?
Yeah.
15 times x. And then the bottom you simplify. And that's it. That's the answer. How was that one?
Good.
Okay. So yeah, that's what you usually do with these guys. When you see something like number 9, yeah, when you see like a radical in the denominator, you have to times the whole thing to both the denominator and the numerator, so it doesn't change the value. But then the essence is you don't like to have radicals at the denominator, and after you do that, you just simplify. So let's do something similar. Let's do this guy, number 11. So what do you do with what I just said? What do you do first?
3 minus 3.
So what's the very first step?
Figure out what the radical is.
So this radical at the denominator, you have to times this, right? Top and bottom.
Yeah.
Okay, so root 3a. Let's just start there. So root a, 8a, 4, and then root 8a squared, right?
Yeah.
And then so the bottom, you simplify the bottom first. Let's not do anything to the top yet. And then says root 8a. And then so the square kind of pretty much cancels out the roots. So it's just 8a. And then, so now what do you do?
Multiply the square roots on the numerator.
Okay, so now you distribute it. So let's see. Sometimes, you just gotta do it and see if something happens. So minus 3, and then you have this 3a times the root 8a over 4 8a. Okay. So what can we do? Let's see. This right here can be combined, right?
Yeah.
Just see what they did. So 3 root 8a minus 3/24 a squared. There's an a squared here. So 4 8a. So what can we do with this a squared?
Add it to the.
So it's inside the radical. So square root of a squared is what?
I don't know.
Okay, so something like this. So you have this 3 root 8. I would probably just split them. Let's just leave this guy for now. You do this guy square root of 24, right? You have square root of 24, right?
Yeah.
And you have a square root of a squared, right?
Mm-hmm.
So square root of a squared is a, right? A.
Yeah.
Okay. So and then so it's easier to see when you split them like that. And then so now you rewrite them. And you say 3 root 24. And then I would probably put the a like in front of the radical. So you have that guy. And then this 3, let me see if we can simplify. So this right here, this 8, and then this 24. We can do something with those, right?
Yeah.
And then so let me just do this for now. So like when you have things inside the radical or the square root, you want to look for things that can be canceled out with the squared. So like, for example, 8. How do you make 8? That's how many 2's do you have to time? 3 times, right?
Yeah.
So you have 2 times 2 times 2, right? And then you have 8. Okay. And then what about this other guy? 24. How do you make 24? You have 3.
3 times 8.
3 times 8, right? But what is 8? I wanna get 8 out of itself. So in terms of 2, 2. Same thing with this guy, right? 2 times 2 times 2, like that, right?
Yeah.
Okay. So there we're getting somewhere. So 8a. And then so now 2 times 2 is 2 squared, right?
Yeah.
So let's try to write that like simply. So 2 squared times 2a minus 3a. 3 times 2 times 2 squared divided by 4 times 8a. Okay, so that's 3. And then what I usually do after this is you want to cancel out this 2 squared. So I would separate them. So like this, 2 squared times it by 2 over a, root 2a. And then minus 3a. And I would do this. 2 squared again, root 3 times 2. 4 times 8a. Okay, so this 2 squared, you can cancel out the 2 squared, right? The squared.
Yeah.
Cancel, 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 cancel. So now, what do you have in there? You have pretty much the 6. Let me see where we're at. So now you have 3 times 2 root 2 of a minus 3a times 2 root 6 divided by 4 8a. There's a lot of simplifications in this one, but let me think what you can do. So you have this 2, right?
Yeah.
You have this 2 right here. Let's see. 2 times 2, yeah. So you have this 2, you have this 2. And then that 2 can cancel out with a 2 at the bottom, right?
Yeah.
Okay. Let me just rewrite this another way. So 2, and then I'm gonna make them all timesing this guy inside. Minus 3a root 6. Okay, the 2 came out now, but then I want to take out a 2 from the bottom. So it's gonna be 2 times 8a. Yeah? Right?
Yeah.
Okay, so the 2 cancels out, right?
Yeah.
Okay, now we're good. So 3 root 2a minus 3a root 6 divided by, and then let's just times the 2 and the 8, so 16a, right? Yeah?
Yeah.
And that's what they got. 3 root 2a minus 3a root 6 over 16a. Yeah? Okay. So yeah, what do you think of that one?
Has a lot of steps.
It's a lot of steps for radicals, yeah, with fractions. Radicals with fractions are usually like this. And then they have variables as well. When you have, what you want to do with the radicals is just keep the rules. The rules is to not have radicals at the bottom. And after you pretty much what we've done is we have to take a look at what's inside the radical and see if we can take out and cancel out 2 squareds, the squared, so that we can take it out of the radical. And after that, it's just algebra. You just keep on simplifying. You got to do more. Try to do more of these so that, like, I guess for this next one, since we pretty much done 2, I'm gonna ask you how to do it step by step. So let's do something harder. Kind of similar to what we did. What do you do first? Number 14.
Multiply the one on the bottom to the top.
Okay, that's the very first step. So times the top by the bottom. So 3k cubed. And then the bottom is just squared, right?
Yeah.
Yeah. So that's pretty much the very first step, always. And then so now what do you do?
Multiply them
This guy?
on the, yeah, those.
Okay. So let's see. I'm just doing it step by step because seeing all the steps is always good until you can finally do them mentally. So 3k cubed and plus 3 root 2k root 3k cubed. Then, so this just cancels out the radical. So it's 3k cubed. All right. So these radicals, you can put them in the same, right? You can combine them. 5 times 3, and then k 4 times k to the cube plus 3 2 times 3 k times k to the cube. Not skipping any steps. What do you do now?
You can you cross out any of the 3's?
Oh yeah. Let's see. Let's think about this one. Not yet, because they're inside the radical. So let's try work with because this guy is up here, right? But there's no 3 down here. There's no 3 outside the radical.
Yeah.
So let's try simplify the radicals first. These guys. So let's do that. So 15. I mean, I guess you could do 5. Yeah, I'm gonna keep them like this in their factors, prime factors. And then so k 4 plus 3, right?
Yeah.
And plus 3 root 2 times 3. And then so k1 plus 3, right?
Yeah.
Divided by 3, k to the cube. All right, so let's just actually do the addition. So that's k to the 7th plus 3, 2 times 3, k to the 4th, and then 3k cubed. Okay, let's take a look at this. So, let's see, 3 to the 6, that's good. They have k squared. There's the k disappeared on that end. I wonder why. Let's see, root 3k, k cubed to the 4th. So this k to the 4th, what can you do with this one? So let's see. So this k to the best thing I would say is try to separate the radicals so it's easier to see. So like you have this k squared, right?
Yeah.
And then this is squared.
Yeah.
K squared is k to the 4th, right?
Yeah.
This right here is the same as k to the 4th. And then let's try to do the other one. So 5 times 3. And it's k to the 7th though. This k to the 7th is the more difficult one. So let's see if we can separate that. So let's see, k to the 7th, and they got k out of it. 6, 3 times 2 times. You could separate it out. 2 plus 5, no. What did they do? Oh, maybe they gotta say 4 and then k to the cube. And did you get? So that's k squared. Yeah, sometimes some of these are you gotta just go through the process. So let's see. It's the same thing as this guy. 3k to the cube. So that's a root 5 times 3. K squared squared k cube. So k squared comes out. Let me think. Oh, actually, hold up. What are we doing here? Why don't we turn these into fractions? K 7/2 and k 4/2. There you go. That seems easier to look at. K 7/2. 3 root 2 times 3 k to the squared divided by 3k to the cube. And let's see, can we get a k cube out of both of these guys? Let me see if we can. Oh no, you can't get that. You want k at the bottom. So can you get a k squared?
No.
Like this guy can, there's a k squared here, right?
Oh yeah, I thought you said k cubed.
Okay, so there's a k squared here. So what I can do at the bottom right here is, here, look at this. This is usually these are the tricks that you have to play. So you have k times k squared, right?
Yeah.
Which is k cubed, pretty much. And then this k squared, I want this to cancel with something up here and up here. I want that to cancel something. So right here we have a k squared. That's good. Here we need to make this so that we can cancel a k squared. Let's take a look at that. 5 times 3, and then this k. Let's see, 7 divided by half. I can do 4 divided by 2 and times it by that's 3 divided by 2. Right? Yeah, I can do that, right?
Yeah.
Okay. And let's see what happens. So this one, let's just say this is 2 already, so that we can cancel it out. 2 times 3 k squared divided by 3k times k squared. Okay, let's cancel out the k squareds. Cancel that guy, cancel this guy, cancel this guy, right?
Yeah.
And let's see what we end up with. So 5 times 3 k 3/2 plus 3 root 2 times 3 divided by 3k. All right, let's see what we're supposed to end up with. So 3k, okay, that's good. I got 15. And then I got 1k and then 1/2, which is good. I think we're done. I think we're pretty much done. So now let's just combine them. So this guy, whatever we have, so that's 15, right?
Yeah.
And then this right here, you've seen this before. Like what you have to do here is, I would just do this. K 2 to the halves times k to the 1/2, right? That's the same thing,
Yeah.
right? And then so let's simplify this other radical. 3 root 6 over 3k. Now one last simplification. This go to k2 to the halves is 1, right? Or it's just k, right?
Yeah.
Okay, so that's k. Let me put that in front of the root 15. What about this guy? This is square root of k, right?
Yeah.
So you just put that inside the radical, like that. And then everything is pretty much the same. And that's what they got. How was that? A lot of this is just, the hardest part of this is figuring out this part.
Yeah.
And then like a bunch of this, like what do you have to, like this guy, like why do you need to split the bottom from like k cubed to k times k squared? But that's what you have to do. Is that easy, or do you want to do more of that?
I think it's kind of easy.
Okay, so let's move on. All right, it's just it's just arithmetic. You're gonna just take a look at it. For the most part, it's just sitting there and then figuring out what gets cubed or what gets split.
Yeah.
And then you want to do it fast. Then the more you do it, the better you get. All right. Let's try to. Actually, now what time is it? Yeah, I think this is a good time. I actually want to talk about graphing, like graphing these guys. before you guys actually touch on it, I know we talked about multi-step equations, and this is some of them. But after you do that, for the most part, you want to be able to graph these guys. So let's just move this guy a little bit to the side here because I want more space. So we'll do some of this, but let's just talk about how you graph this. So what if you had like y equals like 2x? Let's not do the intercept. Like y equals 2x, yeah? Like after you do the simplification, for example, this is obviously not the right one, but then after you do the multi-step, you get an equation like this, yeah?
Yeah.
And then so the next step after you simplify it is to graph it. And how you would graph something like this is in a Cartesian plane, y and x. All right?
Yeah.
So you have y and x. And then what you want to do here when you're graphing these lines is figure out values for x and then values for y. For the most part, that's the easiest way. There's another way of taking a look at this. The easiest way is, have you guys talked about slopes and intercepts?
Not yet.
Not yet. Okay. Okay, we'll talk about it. So the general form of a line, this is a line equation. Line equation is the slope-intercept form. There's another line, but then this is the easiest I can say. Is the slope-intercept form of a line equation is y equals mx plus b. So y equals mx plus b. And m right here is what you call a slope. This is the slope of your line. And b right here is called the intercept, the y-intercept. Yeah?
Yeah.
And then let me define how you get the slope first. So the slope is just, when you're taking a look at a line, that it's kind of like this. So the slope is this rise over run. So this right here is your slope. This right here. So m equals rise over run. So that's in words. And then the intercept, this guy right here, is pretty much where do you, like when you're saying intercept, what you have to do is where does it cross the y-axis, like crossing the y-axis. So this guy right here. That's in words, but in math, what that means in math is you have to plug in 0 for x and then solve for y. So where it crosses, where the y-intercept, what is a y-intercept? It crosses that's where the line crosses the y-axis. And how you get it is you plug in 0 for x and solve for y. And then that y is the y-intercept. Does that make sense?
Yeah.
Okay. This rise over run, you've seen it as just the grade or the slope, hence slope of the line. The mathematical way is rise over run. And just to kind of like define that more, so what if you had two coordinates, like maybe like x1 and then y1, right? And then you also have another coordinate, x2, y2. And just to do plainly what I mean by that is, what if you had this guy, right? This is like x1 and y1. And what if you had something like right here, x2 and y2? So those are the coordinates, right? x1, y1, x2, y2. And usually this is how they present these problems, is they give you like two coordinates, and then you have to find the equation of the line. And after you find the equation of the line, you graph it. Yeah, that's like the process.
Yeah.
You're given coordinates. You need to get the equation, meaning you have to solve for the m and the b. And then after you get the line equation, you can graph it. Let's talk about the steps for that. Like, for example, what would you do, for example? So what if you had example, What if you had like maybe 1, 2 as your first coordinate, and then the other one is, I don't know, let's just say it's like 3 and 5. Or 1, 2, let me just make this 5, 6. There you go. Make it easy. And then so very first thing is, and then what you want to find, so you're given this, what you want to find is y equals mx plus b and graph. So the answer, very first thing you would do here is you need to find m. Yeah?
Yeah.
So m, what was m? M was slope, right?
Oh, yeah.
Yeah, so m is the slope of the line. And then so once you know the coordinates, and then how do you get m again? M was what? Rise over run?
Yeah.
Rise over run. Okay. And there's another way. So that's just in words. Now I'm gonna define the way you find it, knowing these coordinates. Rise over run. So the rise would be the difference in the y's, right?
Yeah.
And the difference of the x's, the horizontal, right?
Yeah.
So that's the equation. M is y2 minus y1 over x2 minus x1. So what is our y2? So remember, this is x1. Let me just, this is x1, y1, x2, y2, right?
Yeah.
So tell me the numbers.
Wait, what?
This guy. So this is the variable. Tell me the numbers to put in here. What do I put up top? The numerator.
Oh, 1,
So y2. What is y2?
2.
This guy, right? 6. Yeah, 6.
Oh, yeah. 6.
6. And then what's y1? This is y1, right?
2. Yeah.
So minus 2.
Yeah.
And what about the bottom? What's the equation at the bottom?
5
5 minus what?
minus 1.
Perfect. Okay, and then you just do the arithmetic. So what is that? 6 minus 2, that's 4, right?
Yeah.
Over 4. It's 4 over 4, yeah?
Yep.
So what is 4 over 4? That's just, your slope is 1, yeah?
Mhm.
So your slope is 1. That's good. We found m. That's the very first step. Next thing is you have b. And what was b? What was b? The y-intercept, right?
Yeah.
So b is the y-intercept. And don't worry, we're gonna do more of this, and then like so that you can get the steps and what the terminology is. So the b, how do you get b? That was in words. What did we mean by that? This is the y at which x is 0, right?
Yeah.
And then another way of saying that is plug in 0 for x to get y, and that y is the y-intercept, or b, right?
Yeah.
Okay, so let's actually do that. Before like, where are you plugging x in? Like where is this? You plug in x where, right? Like this 0. Where's this that you have to plug in? So do you remember you got m, right? You got
Yeah.
m from here. And then what was the equation of the line? Y equals mx plus b, right?
Mhm.
So you use this equation and plug in what you know. You plug in. Why is it doing that? You plug in m 1 for m, right?
Yeah.
So you do this. Y equals 1x plus b. Yeah?
Yeah.
So you're almost kind of done. So you have 1x plus b. And then this b is the same b that you have to solve for. You have to solve for this b. Solve for b. And but you have y and x here, right?
Yeah.
So what do you do with that one? How do you know those numbers?
Divide by 1 on
So
both sides.
what I would usually do, let me look at this one. Plug in 0 for x. So no, like, so you have this line is supposed to it's supposed to pass to these two guys, right?
Yeah.
So why don't we just pick one of them and plug them here? So what I mean by that is, so for example, you have this y2, right? Or 1, 2 as one of the
Yeah.
coordinates. And then this, and then this is just x and this is just y, right?
Yeah.
Okay. So plug them in here and solve for b. So you have y equals 2, x equals 1. So 2 equals 1 times 1, right?
Yeah.
Plus b. Solve for b. So 2 equals 1 plus b. And then so minus 1, right?
Yeah.
And this is 1 equals b. So b equals 1. So to relate it back to what we just said here. So this is the math. This is the terminology. This is the b. So this is the v, the y-intercept. And your x here has to be 0. Let me just show you what I mean. So like now that you have b, and then the equation of your line now is y equals 1x plus b, which is 1, right?
Yeah.
So this is your equation of your line. Now let's actually graph it. So graph. And so I would probably lay out like y like this and x like this. And let's see what my coordinates are. It goes all the way to 6. So I'm going to go up to 6. 1, 2, 3, 4, 5, 6. So that's 6, 5, 4, 3, 2, 1. 1, 2, 3, 4, 5, 6. 1, 2, 4, 5, 6. Okay. And let's just actually graph 3 points. We actually have 3 points here. So we have like the first one, 1, 2. And then we also have 5, 6, 5, 6. And then we have this other guy, right? We have 0 and 1. How did I get this on? This is the y-intercept. This is the y-intercept. Yeah?
Yeah.
So I have 0 for x. And then this 1 right here is the same one right here, which is the b. So that's automatic just by looking at this equation. So let's actually plug these points in, like, and then connect them with a line. 1, 2, 1, 2. And then 5, 6. And then 0, 1. Yeah?
Yeah.
And then you just connect the dots. There you go. And then I guess you can just say this. Sometimes I do this. Y equals 1x plus 1. And then m equals 1. B equals 1. And then is the slope really 1? It looks like it's 1, right?
Yeah.
Rise 1, run 1. The intercept here is 1, where x is 0, and then y equals 1. That's the intercept. And that's it. That's how you graph these algebraic one variable equations. How do you like that one?
It's confusing.
Okay, I know that, but you guys will touch on this after you do the multi-step stuff. But let's do another one. So what part is not clear?
I don't know.
The slope one?
Yeah.
Okay. So let's try to do something similar. So with the slope. So, for example, what if you had random numbers? So let's just say 3, 5, and then you had like 0, 0, 3, or like usually I would put the smaller one first. Let's do 0, 3, 3, 5. You're usually given these guys. So when you get your slope, the equation is just y2 minus y1 over x2 minus x1, right?
Yeah.
And then what is your y2 here?
5.
Yeah, 5 minus, what's y1?
3.
3, okay. And then what is x2?
3.
X2 is 3, and what is x1?
0.
Okay. And you simplify it. 5 minus 3 is 2 over 3, right?
Yeah.
And this is your slope, 2/3. This one's not as easy as the other one, which is 1. So just to talk about the slope, this is just arbitrary. This is not the equation of the line. You're rising, this is your rise 2, and then you're running 3 units, right?
Yeah.
So for example, I mean, you could technically just graph this already, because like 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 5, and then 5. So you have this guy 0, 3, 0, 3. You have this guy 3, 5. This guy, right?
Yeah.
So if you rose 2, so let's say you went 2, right? 1, 2, right?
Yeah.
And then you run 3 to the right. 1, 2, 3. That's your slope, right?
Yeah.
Your slope is just your grade of your line, or in other words, your rise over run. And then these points should connect them. So right there is, I guess, arbitrary, that's your line. But we still need to figure out, in this case, I think I've already given it to you. So we got M as this guy, right?
Yeah.
We still need B, right?
Mm-hmm.
And what was B? B is your y-intercept.
Okay.
And then this is when x equals 0, right?
Yeah.
But what is this guy? I already gave it to you, really. You have 0 as your x, and it crosses the y-axis, which is this guy. So this is your B. Your B equals 3. Does that make sense?
Yeah.
Okay. We didn't have to go through all that math because I gave it to you already. So you have M equals 2/3, and you have B equals 3. Can you define the line? Mx plus B, right? Y equals mx plus B.
Yeah.
So you have M and you have B. So y equals 2/3 x plus 3. And that's your line. Yeah?
Yeah.
That line is pretty much this guy. Y equals 2/3 x plus 3. M equals 2/3. B equals 3. Just for completeness. All right. Let's actually do something like, where's the 2-step stuff? Oh, it's right here. I want to see if they're actually okay. Nah, let's just do this. We'll do that next time because you guys are already doing that one. Let's do another one. So just to do more of this, so you have like 2, maybe like 1/2, and oh yeah, maybe yeah, we'll do one of this, and then we'll do the one where they give you the slope, and then you have to figure out the coordinates. And then so this one's 3, and this one's 6, or 3/5. I don't even know if this can work. Let's just make it 1/2, or 1. Okay. And these guys, these two coordinates, your line runs through them. So you have to find y equals mx plus b and graph. So what was the very first step?
M
Find m, right? Okay.
Yeah.
M equals
M equals y1 minus
y2.
y2
It's always
minus y1
y1. Yeah, it's always the second one. And then x2
minus x1.
Okay, good. And so what is your y2 here?
1.
1. Okay, and what is your y1?
3.
Your y1? This guy, right?
Oh.
1/2.
Yeah.
Yeah, so this one is negative. So you can have negative, you don't have to have positive slopes. What is your x2?
3.
3, and then what is your x1?
2.
Okay, so you just have to, actually, no, this isn't negative. I wish it was a negative one. I should have done a negative. We'll do that on the next one. So 1 minus 1/2 is 1/2, right?
Yeah.
1/2, and I guess this is just 1. So your slope is 1/2. Yeah?
Yeah.
Okay, good. So rise is 1 and run is 2. And what's the next step? Find b, right?
Yeah.
Yeah, y-intercept. Okay. So how do you get b? You put m back in the equation, or in the equation of y mx plus b, right?
Yep.
So you put the m here, so 1/2 x plus b, and then you take one of your coordinates and you put the x and y in there. Yeah.
Yeah.
So x is 3, y is 1. So plug those in. So you have y is 1, so 1 equals 1/2. X is 3 times 3 plus b. And you solve for b. 1 equals 3/2 plus b. So minus 3/2 minus 3/2, right?
Yeah.
And then so this is 2. I guess you have a negative. So that's going to be negative 1/2 equals b, right?
Yeah.
So negative 1/2 equals b. And then now let's rewrite the line equation. Y equals mx plus b. So that's y. M is 1/2. B is negative 1/2. So that's what we have. Now let's graph it. Graph. So let's see what our coordinates are. So we have 2 and 1/2. We have 3 and 1. And we know the y-intercept, right, from the line equation.
Yeah.
And what is that? What is your x in the y-intercept? 0, right?
Yeah.
And then so it's 0, negative 1/2. So that's our third point. Let's graph it. So you have this y axis, and then you have this x axis. And let's see where we have to go with our x. I guess we could space it out more. 1, 2, 3. 1, 2, 3, and then 1. Oh no. 1, 2, 3. 1, 2, 3. So let's do this one first. 0, oh yeah, negative. 0, 2, 3, negative 1, negative 2, negative 3. 0, negative 1/2. So 0, negative 1/2 is here, right?
Yeah.
So negative 1/2 is there. And then this one, 2, 1/2. So 2, 1/2. Yeah?
Yeah.
And then 3, 1. 3 and then 1, right?
Yeah.
And that's it. You do your best. Usually when you're doing these, you have like a grid paper. So it's easier to count, but you just connect it like this. And that's your line. And for completion, just write the equation of the line in the graph paper if it's given to. M equals 1/2 and B equals negative 1/2, which is this guy. And the slope is here. This is 1/2 over 1. Yeah, or in other words, let me see, 1/2 over 1, that's what we got, but it's actually 1 over 2, right? Yeah? Does that make sense? Hello? Oh no. Hmm. Hello? Hmm. Hello?
Hi.
What
My
happened?
cut out.
Oh, yeah, that's been happening a lot lately. Okay. Actually, yeah. So did that make sense?
Yeah.
Okay. I think for now, I'm gonna actually I didn't give you any worksheets on these, like graphing these lines. But I will. Let's cover this more later. And how was this though? So we did kind of like 3 of them or 4. Do you think this is doable? I know it's kind of new, but do you think it's doable?
Yeah, I think I get it now.
Oh, perfect. Okay, yeah, you just gotta do more of it, and then just to extend it, you know how like we talked about inequalities last time? Not so there's no equal sign, like it's like this.
Yeah.
So next time, after we review this more, I'm gonna add in the inequalities again, and then it's really easy. So when this is greater than or equal to,
Yeah.
you just shade the top side. You just shade this guy because it's greater than, right?
Yeah.
And if it's equal to, this is a solid. If it's just greater than, this is not solid. It's a dash line. And obviously, if it's less than, everything's in the bottom. So yeah, we'll talk about that next time. But yeah,
Alright.
enjoy your week and then see you next week.
Thanks. Bye.
All right, have a good one.